to the Jarring Science Club. I'm your host, Brenda. Today we're going to be doing an ice race. Here's what you need. For this activity, you will need 3 jars, all full of ice. You will also need a lid for one of the jars. I'll be going outside to show you clips from our experiment, but to set this up, you need to set your jars in 2 different locations, one in the shade, one in the sun, and then one covered in the sun to see if that influences the temperature or melting speed of your ice. Once you have that set up, check on your ice every 5 to 10 minutes and then see how long it takes your ice to melt and which one melts the fastest. All right, well, let's get to it. Got our 3 jars of ice here. And we're just gonna put them in different spots of the yard. I'm gonna put one in the sun, one in the shade, and one in the sun with a lid to see if that makes a difference. Here's the one in the shade. We're gonna come check back in about 5 minutes and see how it's doing. All right, here's our 2 in the sun, one with the lid, one without the lid. If you don't have a baby helper, it'll be easier to keep your lid on. It's been about 5 minutes and the ice is already starting to melt. You can see the line there in the bottom. So let's check the temperature with our thermometer and see how cold it is in the jar. So it's taking the temperature of the water. Looks like it's about 35 degrees. So here we are about an hour later, and the ice is fully melted. Let's see what temperature we have here. Looks like in the shade, the water is about 63 degrees. Let's go check it in the sun. It is very bright out here. I can hardly see. All right, let's see what temperature this water, this uncovered water was. I don't know if you guys can see that, but it is 94.5 degrees right there. And let's check the shaded one. All right, here's the shaded water, and it is 89 degrees. So the cover did actually help a little bit, but there is a huge difference between 60 degrees and almost 90 degrees. So the shaded water is about 4 or 5 degrees colder than the unshaded full sun water, but both of them are about 30 degrees more than the water in the shade. Here's the science. You just conducted an experiment on how much the heat from the sun can affect how fast ice melts. Depending on how hot it is where you live, you may have similar results to us, or your results may be very different. In our experiment, the ice completely melted in our sun jars within about 20 to 30 minutes and melted fully in the shade within about an hour. But the most interesting thing was that in the shade, the melted ice stayed in the neighborhood of around 60-ish degrees Fahrenheit, while the water in the sunlit area got up to around 90 to 100 degrees. Even though they were both outside for the same amount of time, the shade made a significant difference in the temperature of the water. This sort of scientific research is a very basic form of what actual scientists and engineers do to figure out how to keep things cool or hot. If a scientist or engineer was looking to keep a house cooler, they would use materials that provide as much shade as possible. So they would use things like trees maybe to block some of the sun from coming into the windows. Maybe they'd use coated windows. Maybe they would coat the windows with a shade to keep less sun from coming in. And in the opposite case, if they wanted to have something that pulled in as much sun as possible, perhaps to operate a solar panel, then they would create dark surfaces that absorb as much sun as possible so that they can harness that energy. But before you can create products that either reflect or absorb the sun, you have to know how sunlight works. And that's what we were learning in our experiment. Did you have similar results to us, or do you live in a more temperate climate? That's it for today. See you next time.